G'day again, just for the final video of vector functions, and this video is on, I'm just going to do speed. Speed. We've been looking at vector functions. It's things that are moving, sort of thing, in a vector. So at each point in time, we've got a position vector pointing to where the position of the particle is. So it's pointing all the time, and as it's changing position, then you're getting different vector functions. So velocity functions. So when it's here, the velocity is out in that direction. As it changes around, here it's that direction. It follows the line. So there's the velocity, and there, up here it's up in that direction. There it's they're always tangent to that line. They're all the velocities. So how do we find? So they're the velocities, and when we're finding velocity, it's always a function of t. So how do you find the speed? If you remember what speed is simply the magnitude of velocity. We don't care about direction, we just want to know how fast is this frickin' thing going. Speed, it's the magnitude of vt. In other words, if you're trying to find speed, all you need to do is to find the magnitude of vector vt, and that's what we're doing. And so, and usually that's the square root of the xt function squared plus the yt function squared plus, if there's a z, the zt function squared, that sort of thing. If the velocity function is x of t I plus y t j, etc., plus z t k. Okay, so that's what we're doing here. We're going to show you a couple of different examples, and we're trying to find out what the speed is and what the maximum speed, minimum speeds, things like that. Okay, so let's just hack straight into an example. So an example, let's find the minimum speed of rt equals, I've just got it written down so I better make sure of it, 2t plus 2I plus t squared minus tj. Okay, so there's our vector function. Let's have a look at it. Let's find the speed. To find the speed, there's something you need first. We need the velocity function. So our velocity function is r dot t, which is just the derivative of this guy. So let's take the derivative. So the derivative of 2t plus 2 is just 2. So it's just 2i in the I direction. That's nice and easy. Plus, what do we got here? The derivative of this is 2t minus 1. So 2t minus 1j. So there is my velocity function, r dot t. Fantastic. So speed is equal to the magnitude of our velocity function, and that's equal to the square root of, I'm just careful not to go through that, the x function squared, so 2 squared, plus our y function squared, so 2t minus 1 squared. Expand her out and play around with her a bit. 4 plus 4t squared minus 2t minus 4t plus 1. Rearrange it a little bit. We've got 4t squared minus 4t plus 5. Now, how do we find the minimum speed here? There's a couple of ways you could do it. My personal favourite is to complete the square here, and you can clearly, I find it really clear way. You could also take the derivative of this guy to have a look and see where might it have a minimum. So a couple of ways you can do it. Today I'm just going to complete the square. So I'm going to take the 4 out the front. We're going to have t squared minus 4, and t squared minus t. I hear you saying. So negative half divided by 2 is half, plus 1/4 to complete the square. We've actually added 2, so we're going to subtract 2, and we've still got that plus 5 sitting there down the back. So that's equal to the square root of 4t minus half squared plus 3. Now you can see it's easy to see what the minimum speed is going to be. When will this have a minimum? It'll have a minimum where this inside stuff here is equal to 0. So 0 squared, because the smallest that something squared can be is 0. So minimum speed is going to be equal to square root. So when this is equal to 0, so it'll be 0 squared, so 4 times 0 squared, that's just all 0 plus 3. And that's equal to root 3. And let's just say it's meters per second, because I didn't say anything about it in the question. So minimum speed is root 3. When does that happen? Just for completeness sake, that happens when this is equal to 0, so when t is equal to half. So I'll just write that, when t is equal to a half seconds. Okay, so that's how to find minimum. Like I said, from at this point here, you could just take the derivative and you'd get 8t minus 4. Where's that equal to 0? You solve for that, you get t equal to half. You find that that's a minimum, and then you can find the value. Okay, this is just there's a couple of different ways you could do it. Let's just have a look at a more complicated example, but very similar. Okay, let's find the speed. Let's find the min and max speed of, oh, my pen's doing weird things, of RT, not worrying, I'm running out of vector function, they're horrible, equals 2 cos ti plus 4 sin tj plus 2t. Okay. Right, let's have a look at this. Firstly, we want to find speed, so we need the velocity. So our velocity r dot t is equal to, let's take the derivative. Derivative of cos is negative sine, so it's going to be negative 2 sine ti plus derivative of 4 sine. Sine goes to cos, and so what we're going to get plus 4 cos tj plus derivative of 2t is 2. So that's k, plus 2k. There we go. Speed is equal to magnitude of r dot t, which is square root of, and we need to square all of our components. So square negative 2, I'm just going to do it quickly because otherwise I run out of space. Negative 2 squared is 4, so 4 sine squared t plus square this plus 16 cos squared t plus that squared, so plus 4. Great. Now let's see if we can't just sort of simplify this a little bit. What we've got there is, I'll write it out, 4 sine squared t plus 4 cos squared t plus 12 cos squared t plus 4. The reason I've done that is to sort of, whenever you're finding minimums and maximums and things like that, we don't like having a sine and a cos in there. We want them to be both the same, or the one function or something, because they're very hard to distinguish because they're different values for different values of t. Very hard to think about. So what I've done is put 4 sine squared t plus 4 cos squared t. Why have I done that? Because that's 4 lots of sine squared t plus cos squared t, which is equal to 1. So that's 4 times 1. So that's equal to 4 plus, so that all is equal to 4 there, 12 cos squared t plus 4 equals, let's write it out again, 12 cos squared t plus 8. Alright, so let's have a look at the max speed. When will this expression here be at its maximum? It'll be at its maximum when cos squared t is equal to 1. That's the biggest that cos squared can be. So its maximum there will be 1. If that's 1, 12 times 1 is 12. 12 plus 8, you get root 20. And so meters per second. That's the maximum speed that it can be, because cos squared, the biggest that can be is 1. 12 times 1 plus 8. Minimum speed Don't get fooled here. That's a classic question here. Minimum speed. What's the smallest that cos squared t can be? Most people go -1, -1. Well, no, the smallest that can be is 0. Because what's -1 squared? +1. The smallest that can be is 0. 12 times 0 plus 8 is just root 8. We could simplify those two. 2 root 5 and 2 root 2. Okay, so that's how you do that. Speed, you definitely get asked these in exams and things like that. They love asking these questions. Make sure you know how to find speeds as functions of t, but also how to find maximum speeds and minimum speeds. Enjoy.